Hello, this is Honors Chemistry Chapter 2. We're going to go over scientific notation and the metric slide. So scientific notation is a way of writing really big or really small numbers. And we're going to have a first factor, which is a number between 1 and 9, like we have here, 6.022. And then we have some power of 10 afterwards. So this is times 10 to the 23rd power. So what you're going to do is you're going to write the first part right here. You're going to move the decimal to the right or the left, so there's only one digit to the left of the decimal. So this decimal right here has to be between the 6 and the 0, so that there's just one digit between 1 and 9 on the left-hand side of the decimal. Then you're going to count how many places you moved the decimal. If you move the decimal to the right, like we're going to here, to get to between the 5 and the 6, then the exponent is going to be negative. If you move the decimal to the left, like we're going to right here, then the exponent is going to be positive. And that's because a negative exponent of 10 means you're dividing that number, so that means it's a very small number. And a positive exponent of 10 means you're multiplying it by 10 to that power, so it's going to be a big number. Okay, let's do these examples as a review. Okay, so A, we have 0.1234567 All right, so this decimal right here is going to move all the way over in between the 5 and the 6. So we get 5.678 times 10. This is a negative exponent because it's a very small decimal. And we had to move the decimal 1, 2, 3, 4, 5, 6 places. So it's to the negative 6th power. B is a really big number, so we're going to have a positive exponent on 10. And there are 5 zeros over here. All right, so the decimal is not written, but it is right here on this number, so that's where the decimal is. We're going to move that decimal all the way over here between the 8 and the 0, so we get 8.052. All of these can be dropped. That's the reason for putting it in scientific notation. It kind of shortens it. And how many places did we move the decimal to get between the 8 and the 0? 2, 3, 4, 5, 6, 7, and 8. So 8.052 times 10 to the 8th power, which is 10 million, I believe, or 100 million. This is 100 million. Okay. And so that's why we have this really big number, which is 805,200,000. Okay, C, 2,000. In scientific notation, we're going to move the decimal from over here, it would be after this 0 is where the decimal was, to the 2. Okay, and it's just going to be 2. You'll see why when we talk about significant figures on Friday. Times 10, how many places did we move it? 1, 2, 3. Okay, and so what this is saying is 2 times 1,000, because 10 cubed is 1,000, would give us 2,000. So these two numbers are exactly the same. This is just another way of writing it. Okay, and last but not least, we have 0.003. So we're going to move the decimal over to the right side of the 3, and we will get 3 times 10 to the negative 3rd power, which this technically means 3 over 10 cubed, which is 3 divided by 1,000, and we would get 3 thousandths right here. Okay, so that is scientific notation. You guys are going to have some practice with those. And we are going to go over the metric slide. Okay, so for the metric slide, we're going to use this chart right here, which you can have on the test. This is another way to do conversion problems. So we've already learned dimensional analysis where we cancel the units. This is a second way to do conversions between units. All right, and so what we're going to do is you're going to find the prefix up here with which you are beginning. If the unit has no prefix, then you're beginning with a base unit. So you're either beginning at 10 to the 0 power, which would be grams, liters, moles, seconds. So any of those SI base units would be here. And then, so we figure out where we're starting at. you are going to find the prefix for the answer you are seeking. If the unit has no prefix attached, you're converting to the base unit. You're going to count the powers of 10. Okay, it doesn't say count the places on the number line because you might not be, like, for instance, if you're going from here to here, you're moving 3 powers of 10. So technically it's looks like one place on the number line, but you're looking at how much the power of 10 changes by. Okay, count the powers of 10 on the number line to get from where you are starting to where you are finishing. Now move the decimal in the number you are converting the same number of places and in the same direction you moved on the number line above. If you move left 3 powers, you move the decimal left 3 spaces to complete the conversion. Okay, so let's do this one example using the metric slide. Okay, so we are given, for our example down here at the bottom, 0.035 decimeters. Okay, I don't like this example because we don't ever use decimeters in chemistry, so that's why I've taken it off of the chart. So let's start with millimeters, because we do use millimeters a lot. Okay, and let's say we are converting those to, okay, well, this says millimeters, so that won't work. Let's change it to kilometers. There we go. Okay, so we're trying to figure out how many kilometers are in this many millimeters. It's going to be a small number. All right, so where am I starting? I am starting right here at millimeters, which is 10 to the negative 3rd power. Where am I going? Kilometers are over here, 10 to the positive 3rd power. So how much does the exponent of 10 change by? It changes by 3 and another 3. So it changes 6 powers of 10, and we're moving to the left here. So we're moving this way. So that means I'm going to have to rewrite my numbers to give myself a little more room. I said 6 places to the left, so I'm going to move 1, 2, 3, 4, 5, 6 with the decimal. Fill in the placeholder zeros right there, and that's how many kilometers we have. Okay, so if we were doing it using dimensional analysis, we would have written our given millimeters over 1, and we would have had to go from 1,000, 10 to the 3rd millimeters in 1 meter, and then we would have had to convert from meters to, 1,000 meters to kilometers in 1 kilometer. And this would be also 10 to the 3rd. Let's keep them the same. 10 to the 3rd and 1,000 are the same thing. So we are dividing it by 10 to the 6th power, which means we would move the decimal 6 places. So we would be doing the exact same thing. So this is just a little bit shorter. Okay. Let me see. I think the next slide is scientific notation. Okay, no. So here are some conversion problems that I wanted to try with the metric slide method. All right, so number 1. Oh, okay, the answer for number 1 is there. I'm going to do it anyways. Number 1, 6.0 milliliters equals how many liters? And so if we go back to our metric slide here, if we start with milli and we're changing it to liters, that's a base unit. We're going to the left and the power of 10 is changing by 3. So I'm going to move the decimal 3 places to the left. Okay, so this would be, instead of 6.0, 1, 2, 3 places, I would get 0.0060 liters as my final answer. And you can see that's what we got over here. Okay, let's try one that isn't done. Let's do this one right here. So number 6, I have 3,000 centimeters, and I'm converting that to millimeters. Okay, so centimeters would be 10 to the negative 2. Millimeters, I'm just going to draw the chart so I don't have to keep switching back and forth, 10 to the negative 3. And so I'm moving to the right 1 power of 10. See how it's just changing from negative 2 to negative 3? So 1 power of 10 to the right, So that means I'm moving the decimal one place to the right. So I would get, instead of 3,000, move the decimal over one, I would get 30,000 millimeters as my final answer. Okay, and let's do this one, number 5. Combining what we just went over with our scientific notation, times 10 to the 5th nanometers equals how many kilometers? Okay, so we are going to, I'm trying to scroll up a little bit. There we go. So we are trying to go from nano to kilo. So if we look back on our chart over here, nano is 10 to the negative 9, and we are trying to get to kilo, which is 10 to the 3rd. So over here, I have nano 10 to the negative 9, and I'm trying to get to kilometers, which is 10 to the 3rd power. So we are moving 12 places, 12 powers of 10 to the left. So the decimal is going to move to the left. There are a few ways that we can do this. We can take it out of scientific notation. In fact, let's do that. This 10 to the 5th power means I'm going to move 5 places to the right to take it out of scientific notation. So I have to undo that scientific notation. So there's 1, 2, 3, 4, 5. So I have that many nanometers. And to change it to kilometers, I'm going to move the decimal 12 places to the left. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it would be right there. And I need a lot of zeros as placeholders right here. Okay, so I would have that many kilometers, right? I'm going to keep it in scientific notation, and if you are moving to the left on the number line, it's like dividing by that number of powers. So let me show you. Let me write it out. 8.75 times 10 to the 5th power. And we are moving to the left 12 powers of 10. That's like subtracting 12 from right here. So 5 minus 12, I'm going to get 8.75 times 10 to the, I believe it's negative 7, and I can double check over here by seeing how many places I would have to move it to undo this. So 1, 2, 3, 4, 5, 6, 7 is correct. Okay, so a lot of different ways you can do this. You can use the old way where we were going over dimensional analysis, where we canceled the units. That's my favorite way, but it's not everybody's favorite way. So another way would be using this metric slide where we just move the decimal right or left based on which direction you're going on our little chart. Or we can use our mathematical skills and leave it in scientific notation. Okay, a lot of ways that we can do that. All right, I am going to do a couple more of these problems since we have a few minutes. And I don't know why. Oh, there they are. I couldn't see the numbers that corresponded. So let's do number 8. Number 8, we have 40 millimeters, and we're trying to change that to meters. So on our chart, if we look back, we have milli on the right, 10 to the negative 3. Meters are a base unit, so that's 10 to the 0. So I'm moving left 3 powers of 10, so I'm going to move the decimal 3 places to the left. So 1, 2, 3, I need a placeholder, so I have 0.040 meters is my answer for that one. Okay, number 9, let's do number 9. I have 2.9 times 10 to the 4th power liters, and I want to change that to kiloliters. And kilo is actually over here. So we have kilo, which is 10 to the 3rd, and liters are a base unit. So liters would be 10 to the 0. So I am moving left 3 powers of 10. Okay, so again, a lot of ways I can do this one. If I'm moving to the left 3 powers of 10, that's like dividing by 10 to the third, so I can subtract 4 minus 3 and I would get 1. I'm going to do it kind of the long way just to help explain it a little better, which is let's take this out of scientific notation, so then I can just move the decimal around. So I have 2.9 times 10 to the fourth. Let's rewrite it in its standard notation. So I'm going to undo this by moving the exponent 4 places. Okay, I'm taking 2.9. You can literally plug this in your calculator if you get confused. 2.9 times 10 to the fourth, which is 10,000, and I would get 2, 9, 1, 2, 3. I moved it 1, 2, 3, 4 places. So that's how many liters I have, and I'm changing it to kiloliters. So I'm moving liters to kiloliters. 10 to the third is how much it changes by, so I'm going to move 3 places to the left to convert. 1, 2, 3, 29 kiloliters. Okay? All right, and what is this last problem? Number 12. Let's do number 12. .20 times 10 to the negative 7 millimeters, and we were changing that to nanometers. Okay, so we're starting with millimeters. That's 10 to the negative 3. Milli means 1,000th, and we are going to the right this time to 10 to the negative 9. How much does the power of 10 change by? 6. Okay, 6 places to the right. So we can take this out of scientific notation by moving the decimal to the left this time because it's times 10 to the negative 7. So we would move it to the left to take it out. I'm going to leave it like this and deal with the exponent. Okay, so I just rewrote the number 10 to the negative 7. If I'm moving the decimal to the right, that means the number is going to get bigger. That means instead of up here we subtracted from the exponent, down here I'm going to add that many powers of 10. Okay, so it's like taking, let's do it in this side, it's like taking 10 to the negative 7th and multiplying it by 10 to the 6th. To combine these two, you add the exponents together. So that's where I got this. And let's put it together. 5.20 times 10 to the negative 1 nanometers would be my final answer. Okay, and we'll do it long way just to make sure that we are correct. So take it out of scientific notation. That means move the decimal 7 places to the left. I'm going to have to do it here. So there's 1, and then 6 zeros. 1, 2, 3, 4, 5, 6. 520. So that's how many millimeters I have. That's this number. If I undo the scientific notation and write out the long standard version. Okay, then I said we're moving to the right 6 places. So I'm going to take this decimal and move it 1, 2, 3, 4, 5, 6 places to the right. And I get 0.520 nanometers. And then if I change it back to scientific notation, I need to move the decimal 1 place over to get 5.2, and I moved it 1 place. And it's a small number, so it's going to be a negative 1 exponent. Okay, so that's kind of tying it all together to do a conversion with our scientific notation. Okay, you guys are going to try these. Try them first and then check your answers with mine. All right. Have a great day. See you guys tomorrow.